So this lesson we are taking a look at what's called the rational root theorem. There's a lot of different parts involved in this, and it's a little bit challenging to understand until you actually put it into practice. So bear with me as I try and explain this. So we're given a polynomial, we'll call it f of x. If this polynomial has integer coefficients, then any potential rational root, remember a rational number is any number that can be written as a fraction. So any potential rational root can be written as p over q. P comes from a factor of the constant term. Remember, the constant is the number, it doesn't have any variable attached. And then q is a factor of the leading coefficient. If you didn't understand any of that, let me try and explain it using an example with numbers. So here's our polynomial. F of x equals 3x squared plus 4x minus 4. So make sure you put it in standard form. P is the constant, so P is 4. It doesn't matter that the 4 is negative in our equation because we're going to take that into account when we set up all of the potential rational roots. Now the rational root theorem doesn't guarantee that we do have a rational root. What it tells us is that if we do have a rational root, these are the only possibilities. So if we check all of these possibilities and none of them work, then it doesn't have a rational root. Okay, so P is 4. Q is the leading coefficient, so Q is 3. What we do now is we set up all of the different possible fractions. Now remember, we're talking about P is a factor of the constant term. So P isn't just 4, P is 4, 2, or 1, because those are all of the factors of 4. So when I set up my fractions here, you will see that those are my numerators. Q is 3. The factors of Q are 1 and 3, so those are all of my denominators, why I have them set up twice, one for each of the factors for Q. So if 3x squared plus 4x minus 4 has a rational root, it will only be one of these options, positive or negative. Now this does give us a lot of options to choose from, and I will show you how to work with this information when we get to some examples. Last vocab term I want to go over is what's called multiplicity. And that's when a polynomial has a repeated factor, or when one of the factors can be written as a binomial to a power. So if the power is 2, it has a multiplicity of 2. If the power is 6, it has a multiplicity of 6. All right, let's see if we can't apply this rational root theorem to our first example. So step 1, when we're solving, we're going to be factoring. So anytime we try and factor, we set it equal to 0 first, because our ultimate goal to solve this equation is to use the zero product property. All right, step 2, determine all of the possible factors using our ratio P over Q. P, remember, is the constant, in this case 4. All of the factors of 4 include 2 and 1. Q is our leading coefficient, which is 1, so that makes it easy for us. The only possible rational roots of this function are plus or minus 4, plus or minus 2, plus or minus 1. Now we're starting with one that we've seen how to factor it so that we can ease our way into this rational root theorem. All right, step 3, use synthetic division to try and find a factor. So basically what we're doing here is guessing and checking. So I always like to go in order, so I'm going to start with 1. Set up our synthetic division. We're missing the cube in our equation, so we put a 0. Negative 3 is our x squared. We're missing an x, so we have another 0, and there's our constant. I'm just going to start with positive 1. We'll see if we can get that to work. Bring down the 1, multiply, add, and so on. Now remember, when you get to the final answer, the last time that you add, if the answer is not 0, that means it is not a factor. So x minus 1 is not a factor of this function. Now I'm way off, so I'm guessing negative 1 isn't going to help. So I'm going to try 2. Now especially if you're doing this in Notability, you could just erase and start over. Bring down the 1, multiply, and so on. Add and multiply, that would be a positive 1. All right, so this time I did get 0, which means that x minus 2, remember the asylum, is a factor. So once you've found a factor, see if you can use other factoring methods to finish. So what we're going to do is we're going to write this answer. Trying to give myself a little more room to work here. So we've got x minus 2, remembering the asylum. We're going to write this answer as a polynomial. We started with the fourth, so we're going to have x cubed plus 2x squared plus 1x plus 2. We still have an equation we are trying to solve equals 0. Now, for those of you that downloaded that app, there was a note on my assignment sheet. There is an app that you can download. Once you get it to a cubic function, this app will give you the roots. So you can just type in the coefficients, and it basically does the rational root theorem for you to figure out the rest of the roots. I, of course, don't have my iPad anywhere near me, but I'm looking at this, and it looks to me like it factors by grouping. So I'm going to hold off in the x minus 2 for a minute and just factor by grouping the second piece. So I'm going to pull out an x squared. For my second two terms, I've got a 1. And I'm going to drop the equation because I'm just factoring right now. So pulling out that x plus 2, I'm left with an x squared plus 1. Bringing back down my original factor, the x minus 2 that I found with the rational root theorem. Now I can set each piece equal to 0 and solve for x. So if x minus 2 equals 0, x equals 2. If x minus plus 2 equals 0, x equals negative 2. And then for x squared plus 1, set that equal to 0, we get x squared equals negative 1. So we've got x equals plus or minus I for our answers. Remember, square root of negative 1 is I. And then plus or minus anytime you take the square root.